in a simulation, and then model validation. So let's start. So this research was performed on Rasagiline mesylate, which is the active pharmaceutical ingredient in the medicine which named Azilect, which for the treatment in Parkinson's disease, is Teva ethical drug. So if we take a look inside the tablets, we could see that we could find the API crystals, which are actually in a specific, very specific PSD, and this is due to the reason that PSD can influence the drug effectiveness in the body, the dissolution rate, the bioavailability, the uniformity of content of the tablets, etc., which means that the final API PSD is a critical parameter. And it all actually starts in the crystallization process development. So the target of this research was to produce a process that can actually control the product PSD, to introduce more effective approaches for development, for process understanding. We do that using lab experiment data and mechanistic model based model from Dynochem. What we did, we went toward the size-dependent growth phenomena. So we took all the data set from this experiment, and we added it to a QMOM model, and refitted all the parameters, including size-dependent growth parameters, and then ran in simulator. And the result was that you can see that the span is captured nicely, but there is still a certain deviation from the final PSD. So now we had to add some data about PSD evolution during the time in order to calibrate the model and to be more precise. So what we did was another experiment in the 3-liter reactor with another set of solute concentration sampling during the time and PSD sampling during the time. And I can show you the fitting results. Fitting results in the 500 ml reactor are here. And you can see the fitting results for the 3-liter reactors are much better. When take a look on the secondary nucleation order and the size-dependent growth parameters. These are quite nice. And we did another experiment in the 500 ml just to get the sensitivity of the growth to temperature, to experiment in 2 different temperatures, just equilibrating this mixture and sampling during the time, then fitting for this parameter, EA growth, gave us the sensitivity to temperature, the growth rate sensitivity to temperature. So the result in simulator was that each 3 vertical dots is actually a sample from the bottom valve, and that was analyzed to give PSD statistical parameters of D10, D50, and D90. As you can see, the span is captured quite nicely, and the evolution, PSD evolution, also captured quite nicely, but we are not comfortable with this sample. This sample has a deviation from the trend, so this sample was taken from the dry product and not from the solution itself. What we thought is that it was broken. So now we did another experiment in the 3-liter reactor. We did another set of sampling with sampling just before filtration and sampling the dry product, and you can see in the table that there is a quite difference in the final PSD. So refitting this to the new set of parameters of PSD evolution, we got the span and the PSD evolution. Study goal was achieved by comprehensive process understanding and calibrated models from Dynochem. Specific phenomena were characterized. Dynochem model that predicts the final PSD was constructed. The model valid operation regime was mapped, and the goal was achieved in a minimal set of experiments. When we tested how much time did it take, we saw that usually that's what happens. We saw that it took the same time as a regular crystallization process development. So we have much deeper understanding here. And this approach will lead to less disqualified batches due to out-of-spec PSD in production, that we all know this issue is very painful for everyone. There will be less milling operations, and overall this is a reflection of the QBD approach, quality by design. So just one last word. For the last 9 years I've been developing processes for innovative drugs in Teva. Scale-up was performed using many tools from Dynochem, which led us to right first time in the production plants. We used many utilities, many models, and etc., which all helped us to perform a very successful scale-up and very accurate one. So thank you, Dynochem. Thank you, everyone, for being here and listening.